You're all.
How you doing, guys? We are Social Giving. I'm Joshua.
I'm Kai.
I'm Alex.
And I'm Kwang.
So let's talk about philanthropy for a second. The concept of philanthropy, what does that mean? It means the desire to promote the welfare of others, and it typically means doing that through large donations of money. Some staggering figures over here are, in 2016, we had $390 billion donated, which is 2.1% of the GDP, which is pretty impressive. And over the past 40 years, that was an $8.9 billion increase each year. Another really important factor is that 2/3 of all donations are actually done by individuals, people like you and me, not Microsoft, not Google. Why is that important? Especially because people that are over 60 are actually 2 times more likely and 6 times more generous when they donate. The stats to your left there, the little chart there, shows a pretty clear picture of the difference there. The people on the far left, the lines on the far left are under 30, on the right are over 60, and then over 75. So why is it that people that are over 60 are so much more likely to donate? Is it because we're college students and we all have debt? Is it because of our culture and nobody cares anymore? Or is it more likely because we're just approaching the problem the wrong way so far? Our solution to this problem, through our sponsor as well, is the idea of social engagement and using that for positive change. So our website, which we'll get to in a minute, will have social share buttons on every page. We're going to have like buttons posted around that you can use to automatically post to Facebook, Twitter, Google, the usual sites. And then we'll have the ability to auto post anytime you do something significant on the site. We're also going to use modern gaming concepts and implement those into a philanthropic website. So we'll have a point system that can be used in various ways. We're going to get those points by multiple visits, certain numbers of donations, certain amounts of donations, and things like that. We're going to have attainable achievements that get users to want to come back for one reason or another. And you can display those achievements through badges on your social media or on your actual profile on the website itself. And one other key important part will be the concept of a tournament, putting a little bit of competitiveness into the idea of philanthropy. So you'll have 2 different groups of nonprofit organizations that you will donate to, and one will wind up with a slightly more amount of the donations depending on how the scale's tipped. And those scales will actually be tipped by the points that you users are being given. Some of the technologies we're using Django. One of the obvious reasons is user authentication. Another really important factor for us is the admin portal, which will be discussed a little bit later on. And that's one of the key reasons for Django. Python is a relatively easy language to use, as everyone knows, so we use it for that reason. We're using Stripe for all of the billing. It's a third-party application that kind of ties together authentication and encryption and things like that, which we really have no idea about, so it's a little bit easier for us to get into and get moved along with. And that'll all be tied together with SQL. In the second part of our application, we'll have a native iOS and Android application. We went with native because although we could make a responsive website with Django, it's not quite as quick, it's not quite as fast, it doesn't feel quite as right in a user's hand. We also wanted to get a little bit of experience in learning Android and iOS.
Okay, so when we first started the project, there was already a senior project team starting it. So there was some stuff hand over from them. First of all, it's the design documents of the software, such as the technical report and the domain models, so we can learn what we actually got on our hands. The work completed report was also very helpful. It helped us learn that what is there and what is not. We also learned about some bugs that existed at the end of the interface, so that was good as well. And not only the design document, but also the code from them. There was a backend skeleton of the system set it up, so we didn't have to worry about that. And there was some basic UI setup as well. Of course, it needs some improvements, but the good thing is that the backend developers can focusing more on the functionalities of the website rather than worrying about getting the HTML to work. And then for the phase 2, our goal are the following. We are going to update the designs to include the mobile API and mobile apps and the APIs for that. We are going to gamify the website as mentioned by Josh. We're going to make it interesting for the younger generation. And we are going to add some events for the users to participate in, such as the tournaments, which adds a little bit competitiveness to the website, and also Day of Giving. It is kind of like a dedicated day to the nonprofit organizations for fundraising. It is like a raw day at RIT. We are also going to redesign the UI to improve the user experience, and later we are going to develop the iOS and the Android apps. These are the things we have completed so far. We have updated the design. We did some extensive refactoring, decoupling some of the models, and generally making the code easier to work with. And we added some functionalities, such as achievement, which rewards user for accomplishments, such as donating X amount of money or logging consistently for X amount of days. And then the opportunities, which are the opportunities for the users to learn about the nonprofit organizations and the problems they are trying to solve, and then reward user after they completed the quizzes or read articles or watch videos. And then we did some system integrations to tying all the models together.
All right, I'm going to talk to you guys about the methodologies we used. So we used a modified version of Scrum. We didn't want to deal with everything Scrum came with. So we did things like remove the daily stand-up. We're not in a work environment. It's not exactly easy for us to meet every day for that kind of thing. So we just kind of removed that part. We still have our 2-week sprints. We tracked our velocity throughout the project, and that helped us planning for future iterations, how we were doing versus how we thought we were doing. We tracked our progress as well with burn down charts, just to make sure we were on a decent track throughout the project. We wrote very formal user stories throughout it. Through our cello, we used the as a user I want to blank so that blank, stuff we learned in class for that. We included other stories outside of just epics and the tasks themselves. We had bugs in there, we had research ones, documentation, maintenance, and we even included features that were out of scope in there. When we were assigning effort points to the stories, we played planning poker using values of 0, 1, 3, 5, 8, and 13. Each member would pick one, and then we'd eventually talk about it and figure out what the value would actually be at. We tried to keep a very clean Git repository throughout the entire project. We did that very formally. Anytime a developer wanted to work on a new feature, they would make a new branch for it. When they were finished the development process, we would rebase just to kind of squish all the commits. And then we had to set up a pull request, which had to be approved by 2 other of our developers. This just made sure that we kept the code relatively clean, bug-free, and just kept up with the coding standards that we had set for ourselves. So here's some examples of our user stories, and on your left we have an epic here. So you can see in the description it has the as a user I would like to earn achievements so that users will feel more rewarded and happy with what they're doing. We also had acceptance criteria in there, so we actually knew what we were doing, when it would be completed, and these were all approved by our sponsor. And on the right side we have an individual task, which is a little bit more granular. It still has a description, just like the epic, but it had more specific details about what it would need, such as this one needed a nonprofit name, an ID, and still had the acceptance criteria just to make sure we knew when the story was actually completed. So since the first team did not do any UI work, we wanted to make sure it was very engaging for our users. So we went through a phase of developing wireframes for just general data management, as well as doing the actual mock-ups. So we have a few here for you. This is our landing page, and this will serve a few purposes. On the left, the Make a Donation button is for users who want to make a donation but don't want to create an account. They can make a direct donation to a nonprofit without it going through a login process. The Get Involved will take users to our events page, which will just tell them what's happening on the website. And then there's also a login button, just so if they already have an account, they can just jump right back into it. Here we have the mock-up of the events page. We wanted to prioritize the events that are happening on the website. So at the top, if there's an active tournament, we will display it. It will tell you what kind of tournament it is. It'll list the nonprofits that are competing against each other, as well as a Participate Now button so that users can directly get involved with it. And we also wanted to list out all the nonprofits that had Day of Giving events for this day, because we just wanted them to get more exposure and an easier access for users to their pages. And the final mock-up we're going to show you is the actual nonprofit's personalized page. They'll have buttons that only they'll be able to see, such as the edit information and purchase additional features. And at the top, we wanted a banner just to show off that if they are having a day of giving, it's at the top of their page. That way users see it first above all other things. Or if they're participating in a tournament, it'll be shown there. Below that, we will have an image carousel where the nonprofit will be able to put in pictures that they want that just kind of show off what they're all about. They'll have an About Us section where they can put their mission statement and anything else they want to describe to us. And below is another way for users to get involved with learning opportunities. So they'll be able to either take a quiz, watch a video, or read an article to earn more points, and those points will be able to be used in selecting winners for tournaments.
So during our development cycle, it was tough for us to develop and expand new features from previous code since the system was tightly coupled. In addition, several models was not complete and compatible with the new features that we want to build. And as a team, we had to spend a substantial amount of time refactoring the previous code to make it better, clean, and easy to understand. However, refactoring the code also break test cases and database scripts from the phase 1. When we start a new sprint with new features, we constantly ran into unforeseen problems. Thus, we had to replan our sprint several times. Another mistake that we made was overestimate user stories in the early stage. We planned to finish way more story points than we actually were able to complete. In the future, our goal is to work on the mobile and the web simultaneously. Part of the development, mobile development work will require us to set up Django API to communicate with the web app, payment system using Stripe, and some of us might need to spend some time learning iOS and Android development. For that reason, the mobile development work might interfere with our web development and create more problems for us to handle at the same time. One of our clients' requirements is that most of our functionalities need to be available for the content creators to be manipulated and managed through the Django admin site. That can be a problem for us to make the backend features abstract enough so that the content creators can easily manage the system. And finally, our README currently right now is mostly about set up the development environment and how to set up the project. Thus, we would need to spend some time updating the documents so that our content creator can understand and be able to use this system without any problems. Even though there are many problems, but as a team, we will work hard and to overcome those problems and deliver what our clients want by the end of this senior project. So for our future plan, this is our roadmap for the next semester. Our goal is to complete the website as well as to start our development for the first version of the mobile applications. As you can see, these are the milestones that our team wants to achieve in the next 5 months. By January, we will release our mobile app UI design for the client. And in February, we will finalize and release an entire new look for the website based on what Alex has shown you in the mockup. Next, we will aim to finish our API implementations to open the communication gate between the web and mobile applications. And our goal is to finish testing our website and set to launch at the end of February. In March, we will integrate Stripe for our mobile applications, allowing users to donate their money. And in addition, users will be able to participate tournaments, events, day giving, and others events through their mobile devices. And finally, we will work on polishing the mobile app, finishing up other features, and that we see fit for the app, and release the first version by April 2018.
Are there any questions?
So you mentioned Django before. Did you go with that? Why did you go with authentication specifically? And was this due to the previously existing Django?
It was the previous team. They had picked out the Stripe, Django, and SQL, so that was just handed to us. The mobile side of it is what we had a deciding factor in.
In terms of like any scope concerns you guys have, for next semester, do you guys have plans if you run into more roadblocks and you fall behind schedule, like what is first on the cutting block, what's most important to get done?
Yeah, we do. So iOS is our preferred device that we're going to develop for, but the new UI will also be responsive, so it will be mobile friendly irregardless. So we're not too worried about that, but we do have a backup plan in case something falls through.
Can you just, maybe I missed it, can you run through what the role of content creators is in the site and how that differs from like and you said you had pages for the specific like charities and how those two differ?
Content creator is the concept of like a non-developer. So Patrick, our sponsor, will basically be running the site himself and doesn't have development experience. So he'll need to be able to create everything in the system himself.
Any more questions?
I may have missed it because I read your late, right? Can you tell us a little bit about if you have is there a testing framework in your test strategy? How are you going to verify this?
Yeah. So we got a lot of testing received from the first team. They got up to, I think, like 90-something% test coverage. And we've broken some of their tests along the way, especially with like the development of new features. We're still at about a 74% test coverage rate. And we're just using the built-in one. It's not JUnit. What?
No, let's see.
I don't really remember.
It's JUnit. Okay.
It's JUnit.
So JUnit.
How are you making sure that people who want to be added as nonprofits are actually using JUnit?
So the way it's set up right now is that if you sign up as a nonprofit, you have to be approved by the admin content creator, which is another reason why that's important. So you sign up and you're in a pending state until Patrick goes through and says, yes, you're verified, and then he makes you active. And you don't have access to anything as a nonprofit other than just seeing actually, you limited access to that. You have access to nothing. You can't log in, can't do anything with your login information until Patrick is verified, and you get an automatic email saying that you're verified and you're ready to go. So there'll be basically grunt work on his side of verifying your tax refund and that kind of stuff, and making sure that you are who you say you are.
Back to testing. How do you go about testing that integration with Stripe?
Stripe actually, we're not fully versed on Stripe yet, but as far as I'm aware, Stripe has its own testing kind of side of it. So they have mock information you can put in that will give you a guaranteed response. So we'll test it through that concept,
Yeah.
and that can be automated as well.
There's like a paid version of it and like a free version. So we have a free developers version in it that the first team developed with. So the functionality exists, but like it's not a live version of it because you have to pay for it. So we didn't want to pay for it until we were closer to our actual release date. So we'll just have to do more testing closer to that date.
Somebody else had a question?
Yeah. So you mentioned you have a thing where like you can take a quiz or watch a video and you test something from different points. Have you considered or do you have anything in place to try and circumvent the situation where someone who's interested in a particular nonprofit just like generates a ton of accounts and then spams
So you're implying that they're going to auto-generate a bunch of accounts and then spam the point system?
Essentially, yeah. So the thing is, it was more like a location-based thing because you can prevent auto signups with something like CAPTCHA, but as for preventing very concentrated locations, spamming the points.
At the moment, that's out of scope. It may come into scope. That's a valid question.
Does your roadmap keep in mind the breaks in particular? Like spring break, for example, and winter break, are you planning to work over those at all for your future roadmap?
Actually, yeah, we're planning on doing a significant amount of work over winter break, and then spring break is a week, so you probably, yeah, most likely.
There are no other questions? Let's thank the team.
Hi everyone, we are Team Abstraction, all caps with spaces in between, and we are making the product Gallery Gateway. My name is Robert McLaughlin.
I'm Bill Davis.
I'm Christina Howard. I'm Kayla Davis.
All right, let's get started. So to begin with, our project is sponsored by the College of Imaging Arts and Sciences, and specifically the School of Photographic Arts and Sciences. And every year they run an honors show where they accept artwork, usually photographs, but also of different types like books or videos. And so students are prompted to submit artwork to a website. That website aggregates all of it, and then it enters a judging period where faculty will log in and submit a yes, no, maybe vote on each piece of artwork. At the end of that judging period, all the votes will be tallied and winners will be invited to attend the gallery. Their work will be hung in the gallery and potentially available for purchase. So currently the software that accomplishes this task is called Cafe. And there are a number of issues that prompted our sponsor to come to us to potentially address. So first, they have a strange concept of a portfolio, and when students submit work, it goes to the portfolio, but unfortunately that doesn't mean it's submitted to the specific call for entry. So students need to take a second step to enter it in before it can actually be judged, and a lot of students are left out, unfortunately, because of that. Judges also have a save button as they're progressing through the series of images, and the button is rather small and forgettable, so a lot of judges lose a lot of their work, which is frustrating. Administrators have to navigate an unfriendly interface and unintuitive workflows. They have a lot of features that aren't actually necessary, and unfortunately you need to navigate all of them to be able to assemble your show in the correct manner. The process for video submission is a little bit clunky. You aren't able to actually submit a video. Instead, you need to submit a photograph clearly indicating that you're submitting a video, and the judges will then navigate to whatever location is hosting the video. Image size is also significantly limited, which is understandably an issue for submitting works of photography, and this makes judging a pain. There's also some strange logistical issues. If you would like to open a call and have an issue with setting it up, or you would like to download all of the photos from last year's submission, you need to email the company directly and they will get back to you. And lastly, it's priced. It's metered by submission, so students are limited in how many works they can submit. And furthermore, RIT needs to pay to put on this show every year. Our proposed solution is a self-hosted system. A few of the areas that we want to address are, we want one intuitive process for submitting photos as a student, so that I always know that when I've finished submitting, it's directly to the call and it's ready to be judged. We want judges to have an intuitive interface that provides a rich experience, including panning and zooming, full-sized images, and auto-saving to make sure that they truly get the best experience. We want to make sure that the administrator only has the features they need and not any of the features they don't need, which will save a lot of time and confusion in setting up. We also want to make sure that videos can be embedded, so YouTube and Vimeo can play directly to the judges. We want, as I mentioned, full-res images, both for judges and for downloading the archive later. And lastly, we would like to use RIT's Shibboleth Auth, because the existing auth system requires an external account, including a username and password that students often forget. This is our domain model, just a high-level overview of the sort of problem that we're solving. You can see everything is sort of centered around a submission. There are multiple types of submissions. So for example, you could submit a book, a photo, a video, and in addition to that, a submission is directly to a call. After the system has gone through and done all of the judging, we also have concepts of labels and reports. Labels are things that are printed out physically and then hung by the artwork in the gallery to know what the title is and who submitted it. And reports are a catalog of information about what was submitted, who submitted it, including orientation for logistical issues.
All right, so now that we talked about the problem, it's time to talk about our process. So before we jumped into developing anything, we decided to catalog our sponsor and then our team needs. So our sponsor, well, both our team and our sponsor wanted a way to get and give frequent feedback on the progress we're making, and our sponsor wanted to see visible feedback frequently. Us as a team, we wanted to clear up specifically UI requirements and kind of get general feedback on that. And we also wanted to work with a process we were familiar with. Through co-op, we had all done some sort of agile process, usually whatever companies called their own version of Scrum. So we decided to do distributed Scrum. This can mean like a ton of different things to a ton of different teams, but for us it means that we do development and stand-ups remotely, and then any other processes or ceremonies we do in person. So I guess one of the more interesting ways that we're doing the distributed part of the Scrum, or a Scrum process, is digital daily stand-ups. We do these through Slack, so we have a stand-up bot that every weekday at noon tells us that we need to post our stand-up status, and we have an hour to do so. So it's the general, what you did yesterday, what you're doing today, and then for if you're blocked, you're supposed to @ the person that's blocking you so that we can resolve these issues quickly. As you can see from these numbers, we're pretty good at the attendance, and it seems to be working for us as a way to keep responsibility. So there's a lot of issues that distributed teams can run into. They're usually with communication and transparency, and so we're using a few tools to try to solve this or mitigate it. And so we use Slack as a way to do any sort of communication we can't immediately do face-to-face, whether you run into a bug or just a general kind of design discussion. And then we have GitHub and ZenHub as a way of course, storing code and then managing the process. ZenHub we mainly use for our product backlog and our sprint backlog to kind of keep track of that. And then when we're actually pushing code, we require PRs that at least have one person's approval, so that more than one person, more than the person who developed, knows what's happening. And we do automated testing too. So, excuse me. So on Tuesdays we end up doing planning, triage, or retrospectives depending on the time of the sprint. When we're doing planning or triage, we end up pointing through planning poker with real-life cards that Rob bought. And then this is all to plan for Thursday's meetings with our sponsor, where if it's the end of a sprint, we demo, and then if it's sometime in the middle, we're either getting questions answered that we've run into, or we're doing this kind of UX, UI whiteboarding thing. So to get into that, initially, when we first went with our sponsor for the first 2-ish weeks, we ended up just gathering high-level requirements. For us, this is the formal user story as, as a blank, I would like to blank. And we filled up the backlog with these stories, and then created an ERD and a domain model to verify with our sponsor that this is what she wanted. Now we do this thing that I think the entire team finds super useful, which is this UX or UI driven development. So we all come in with ideas for a specific feature we really want to drill down into, and we throw that up on a whiteboard, give each other feedback, our sponsor gives us feedback on it, and at the end of it we end up coming up with a good idea for a UI, knowing what our sponsor wanted. And it's useful because it allows the back end to know what to write for the front end, and the front end to have something to write to.
So now let's talk a bit about the technology choices we made. So at the start of the semester, we talked with the CIS system administrators what limitations we might have running our code in their environment. They explicitly told us we couldn't use any Microsoft technologies, but they said they were comfortable, like if we gave them enough documentation, they'd be willing to run anything that we gave them. They did tell us that they were comfortable running the LAMP stack, which is Linux, Apache, MySQL, and PHP, because they currently deploy a number of those apps. None of our team members particularly knew PHP, so there was an internal trade-off whether we ramp up to PHP and have a painless deployment and handoff, or whether we use technologies that we're familiar with and potentially have risks of deployment issues and maintainability issues going forward. So we did have a deliberation process. We all threw out what we were familiar with. We decided it makes sense to decouple the back end and the front end so that our team members could work independently. We also figured that a single page app framework like React or Vue would give us the ability to make the complex user interfaces that our sponsor wanted. As I mentioned, we had no real overlap, but we had all had experience working with web. At the end, we chose to use Laravel, which is a PHP framework, and Vue. Laravel has support for Vue built in, so we decided it would be a natural choice to go with that. However, we did note that that was a risk of learning PHP, learning Laravel, learning Vue, all new technologies to us, and we were monitoring whether we could be productive and deliver our product to our sponsor by the end of the year. So we did, in fact, rewrite. We felt that we were spending more time reading documentation than shipping features. And so with approval from the system administrators, we decided to switch technologies mid-semester. We switched to a Node.js, GraphQL, and MySQL backend on top of a React, Redux, and Apollo frontend. And since then, our team morale has significantly increased. To give you an idea of what our architecture looks like, it's a front-end single-page app built with React and Redux, which talks to a Node backend through GraphQL. We're using the Apollo client and server implementations of GraphQL to help us out there. We're using SQLwise as our ORM to communicate with MySQL, and we're using Passport.js to talk to the CIS Shibboleth proxy server that they run for authentication. Internally, we use JSON Web Tokens for authentication, and we're also shelling out to Graphics Magic for some image processing on thumbnails.
Cool. Thanks, Bill. So now we'll talk a little bit about our metrics. One of the metrics we decided to go on was code coverage. We decided we would want this around the 80% mark, and we implemented this starting on October 31st for the back end. We decided that 80% code coverage allows us to test our most significant features in order to verify that they work. In addition to this, we felt like using this metric is useful because we feel like it's a fair trade-off between testing each of our major features and shipping features for the customer. We decided that this was good for both self-documentation for future groups that may improve upon additional features that we may not do, and it's generally useful for us given our busy schedule. So another metric we decided to go over was velocity. This allows transparency both for the customer and ourselves to show the workload that we can take due to our vigorous academic schedule. Our first sprint shows right here that we were around the 35-point mark. This was due to overestimating and using an unfamiliar frameworks, including Laravel and Vue. Around sprint 3 is when we migrated over to React and GraphQL, which was a lot of migration tickets and other items. Each of these sprints were in duration of 2 weeks, and sprint 4 shows that during the times for exams as well as near Thanksgiving break, and sprint 5 is what we're on. We averaged around 27.5 points per sprint, and we're still slowly getting to a point where we know how much we can take on, along with what other tasks are coming our way with our academic schedule. Finally, here's an example of one of our burn down charts. This is from sprint 4. We decided to go around 18 points because this was during a bunch of midterm exams as well as close to the Thanksgiving break. So ZenHub is really nice, where it allows you to add labels, including milestones, to each of your tickets. We consider a done ticket as a PR merged in or a task completed that's outside of the code. So from the duration of 2 weeks, you can see it go from start to finish.
So now let's take a look at the progress that we were able to complete during the semester. So as users enter the application, they're met with a splash page. They can log into this and they're redirected to the RIT authentication. I'm sure you've all seen that orange bar at the top with your username and password. Once they log in, they're redirected back to the part of the application that's relevant to them, whether they're a student, a judge, or an administrator. This semester, we decided to focus on the administrator functionalities. So administrators can create a show with this fancy date picker, and they can also assign and unassign judges to those shows as they need be. Some lessons learned that we've had for a time box project, we think it's better to favor familiar technologies. We realize that it may be easier if one's writing from a version 1 where they actually have the code to experiment with technologies. But given that there is a deadline to the senior project, it makes sense to use what you know and just build off of that. We also realize that there are trade-offs to using cutting-edge technologies. GraphQL is a fairly new technology, and so the Apollo tool we're using, its documentation is there, but it is lacking on some advanced features and some edge cases. But we found that knowledge sharing with another senior project team who's also using GraphQL has been really helpful there. We also find it's useful to continually reevaluate scope with the project sponsor. We found that certain features that we thought were really necessary at the start of the project, we were able to change into features that delivered the same value but had less time for us to actually develop. Is there any questions?
Yeah. So when I was looking at your technical solution, I saw at the beginning in the front end you guys were deciding sides, but just between you and React, but then you guys moved to React and Redux. Was there a reason you guys needed client state management when you guys started implementation? Because I saw Redux was taken into consideration at the beginning, so you guys added it in.
So Vue has their own state management called Vuex. So we were going to use that with Vue, but we never got to a point where we would need that state management until we actually switched over to React.
Okay. And why did you guys feel like you needed to use a client-side state management?
So our app is fairly complex, so it has 3 different user workflows between each, so we have to maintain different state between all of those, as well as all the data stored that comes in from the backend.
So is this living on CIS's web environment, or the sugar features that had CIS's IDP? So do they handle that, all that, you guys, or is it Firelight?
Yeah, they have their own SAML authentication server, which will redirect the user to RIT. So we merely need to give CIAS exchange certificates and everything, rather than go through RIT's main shibboleth process. Yeah. Yep.
You guys mentioned the coverage. Is that backend only, or is it front end?
So currently that's mainly back-end. It took us some time to do the front end, specifically mainly because what we used ended up being just an enzyme for the front end testing, which was mainly components. And that took a while because we didn't have a lot of experience doing that in the first place, so it took a while to set up, along with making sure we had their environment variables correct for the front end, since these are both they're separate testing.
Yeah.
So you said that you're trying to be very UI UX focused. Do you have any terms for usability testing?
So we don't actually right now, but we are planning to do testing for usability in next semester.
And going off of that, since our sponsor mainly has a lot of the experience and we don't have access to Cafe, once we have more done, we can have her test it and understand if she has any difficulties from ours compared to the previous Cafe.
You guys have mentioned that you're using a lamp stack, but the technology does get more. Is that why did you guys first go with MySQL over Mongo?
So Mongo is more geared towards document database, document style objects, and our data is clearly relational, so it made more sense to use relational database like MySQL.
All right, let's thank the team.
Alright, hi guys. Our team is the Bicycle Touring Companion, and our sponsor is Adventure Cycling, so we've been working with John and David, who are our remote sponsors from Adventure Cycling, and Professor Bolino. So we'd like you to imagine for a minute that you're riding your bike across the country, you're on a bike tour, you're by yourself out in the middle of nowhere with no cell service, and your bike starts experiencing problems. So you know that you need to stop tonight to get food, you know that you need to stop to get your bike fixed, but you're not really sure where and you're not really sure when the best time to do that is. So in the past you might have carried a paper map with you, but we're hoping to have this be on your phone so that you can have offline functionality and be able to find these things while you're on the move. So a little bit about our sponsor. Adventure Cycling was started in the 70s by two cycling enthusiast couples. Today they have over 100 annual guided tours, and they have route information for over 45,000 miles of bike routes. They advocate for the USBRS, which is the United States Bike Route System, and they also publish their own magazine. As an advocate for bicycle travel of all types, Adventure Cycling is one of the major promoters of USBRS, and they envision the BTC to be a community-based resource to sponsor those. So this is the USBRS now. It's routes all the way across the country, and you'll notice that you'll see this again when we do our demo.
All right, so one of our big features that we implemented for this BTC app was vector mapping. This is replacing the old bitmap that the previous team had implemented. And the reason being is that it's much faster loading, it's less load on the network, and scrolling is a breeze and very smooth whenever we do this. So that being said, this is a phone application, so obviously having the lighter load on the network, as well as a smaller data storage for offline mode, are really the key factors in implementing this vector map technology. And so with that, the two big technologies that we were considering were Mapbox and OpenStreetMaps. With the OpenStreetMaps, we would have to have hosted our own server. So essentially we went with the Mapbox, which is a wrapper on top of the OpenStreetMaps that delivers a nice mapping API for us to use, and we can build upon that with layers, markers, basically anything you can think of for online mapping. What else? We have not done the offline mode yet for vector mapping. That is the next thing on our list to do with this, but we are expecting to really increase the effectiveness, and we might not even have to connect to the online Mapbox API very often, if at all, except for maybe updates on the app side occasionally. So, to go into next, we got a demo. And can I make this? Oops, I cannot. Yeah. Now there's the, there we go. Okay, so this is just kind of demoing what you see and how you can kind of see the scrolling and the responsiveness of this map. These are really the key features. You can see it's very responsive. I zoomed it out a whole bunch, and zooming in, you kind of don't lose the focus. You continue to see things, and things appear as you zoom in more for fine detail. And this is really the reason that we implemented the vector map. You get this nice crisp scrolling, and you don't have to load image after image after image for every zoom level. It really takes the load off the network. And let's pause that, or not go full screen.
So next we'll talk about our architecture and what we've actually done. So we're the third team to work on this application. So the first team kind of laid the groundwork and gave us a proof of concept. And then the second team was able to get an alpha beta / version of it. And so what we've done is we've kind of taken everything that they've already had, since there's no point in ripping it all out. And we've maintained a lot of it as far as the client application is concerned, the database, the server. The main thing we've changed is what we just demoed, is our map. We've switched from the tile server that they were using prior, and we're now using Mapbox for the reasons that Dylan had just explained. It's our solution for offline, and it's our solution to help make it more responsive. So this is where the majority of our work has been, and getting more into what we've done with our stack. So as I said, we maintained a lot of the previous team's work. We have CouchDB as our database server, and we use Pouch on the mobile implementation. We have AWS servers that host our web server as well as our database, and we use Apache Cordova. So we're not using native applications. Apache Cordova bundles down our JavaScript files and makes it so that it emulates as if it were a native application on a mobile phone. The major change again is really Mapbox, and it's our end-all be-all solution for offline functionality. What we were able to do was maintain a lot of the code that existed already as far as the UI was concerned. So prior to using Mapbox, they had UI that was using React components, and we were able to use Mapbox's version of a React wrapper, and we were able to salvage a lot of the UI, such as users and authentication, and the way that we add points to our map. So using those libraries, we were able to maintain a lot of what had already existed. Now, as far as our process, we're using Scrum. We have 1 to 2 week long sprints. We kind of modified that as we went along, depending on what we needed to do. So occasionally we would have what we called research sprints, where they would be about a week long, and we would have a lot of spike tickets where we would discuss different technologies. So for example, when we were picking between Mapbox and OpenStreetMaps, we kind of took a week and really looked at what the benefits of using those two technologies would be. And then we came back and did a 2 week long sprint where we kind of went more into what we learned from those spike tickets and created stories off of that. We use daily stand-ups in Slack, and basically the way it worked is if anyone didn't have anything to say for the day, since we were all working and doing other things in our free time, you would just write in the Slack that you hadn't had anything done for the day, what you plan on working for the next day, and if you had any blockers. Otherwise, you just updated your progress for the day. And we're also using Jira to manage our artifacts. We're using it to manage our burn down chart, and it's also good for our metrics because it can track exactly what it is that we'll get into in a couple minutes. And overall, we also put our user stories in there. We imported a lot of them from Git, so the previous team was using GitHub issues, and we just kind of brought them over to Jira, and we're able to import it that way and put our user stories and points in that way.
All right, so we kept track of 2 major metrics throughout this, our sprint velocity and some defect tracking, which we'll go into detail. So first, for our velocity. We had a total of about 5 sprints throughout the semester. These sprints varied in length depending on the week and what we were doing, so some of these might be a little, I guess the word I'm going to use is inaccurate. So particularly sprint 0 and sprint 2, this was what we called our research sprints. Sprint 0 being when we first got the project. We did a little bit of research to familiarize ourselves with it. And sprint 2 being the sprint where we did most of our research for our vector mapping solution. So those involved a lot of spike tickets where we just kind of did research and didn't actually get any tangible work done. But as you can see, at sprint 3, when we started our main implementation, the workload increased drastically and we started closing a lot more stories. And for sprint 4, a similar trend can be seen, just to a lesser scale, because that sprint happened to align with some other times during the semester, like holidays. We plan on using those last 2 sprints particularly to sort of plan out how much work we're going to commit to next semester, since we think those are the best representation of how we could balance the amount of work we dedicate ourselves to. The next big thing is defect tracking. So we expected to spend a little more time on defect tracking this semester than we actually did based on the previous team's performance. But as it turns out, since we were mostly working on the vector mapping solution, we actually spent a lot less time fixing bugs. The first 2 bars on this graph here are a little misleading because those are actually us importing all of the issues that were previously there from GitHub. So most of that red bar weren't issues that we actually introduced into the system. That was what was there before, and we're just putting it in for tracking. But as you can see later, we have a lot less red and a lot more green, and even some of those defects added later were actually due to a lot of package updates that we did, because there were some very outdated packages that were being used, and we were trying to get everything nice and up to date and trying to get the newest packages as we implemented our vector solution to make sure that things were future-proof. So, and the last thing I'm going to cover is that for next term, we actually are considering replacing this metric for something that might be a little more useful for us, such as some kind of performance tracking, since we're going to be doing a lot of tests involving load on the application with a lot of points and being able to work offline.
Yeah, kind of what Carlos just mentioned, doing some more performance testing. We did a little bit of that this semester with basically generating a lot of mock data for these points or markers on the map. And what we found was even at around like 2,000 points, the app gets really slow. And at 5,000, it pretty much breaks the app and you can't do anything. So that's a clear issue for us. We discussed some possible fixes. We haven't really decided on exactly how we're going to do it. We had talked about filtering, whether it's, we only want to see things within 25 miles of you, what's on screen, or we talked about doing point clustering. So if there's like 20 points in one little area, it will show up as 1 point on the map and maybe like a 20 to indicate that there's 20 points right there. And as you zoom in, it will show the points where they are. So one of the reasons that we discovered that the performance is so bad is that every time you move the map, it's recreating React components for each marker, regardless if it's on the screen or not. So as you can tell, or as you might guess, with 5,000 points, that's 5,000 React components all trying to be added to the map. It gets really slow and it's unnecessary. Right, so that's pretty much what we did for this semester. So just to reflect on that briefly, I think when we started, we got up to speed and started working very quickly. We set up productive meetings on Tuesday, Thursdays, and Sundays. And we mostly handled process stuff during those meetings and did development on our own. For vector mapping, we got that in much quicker than I think any of us had anticipated. There's still some bugs in it right now that we'll definitely work on next semester, but just getting the base vector mapping OpenMapGL in is really good. So one thing that we could definitely improve on is the Slack communication. We did do our daily stand-ups in Slack, and I think all of us missed more than we would have liked. So definitely trying to get that as close to 100% as possible would definitely be good for next semester. But overall, I think we're all satisfied with where we're at for this semester, and we look forward to continuing our progress next semester. Yeah, so then for next semester, our plans. We want to, fix those bugs that are currently in the vector mapping solution. Like I mentioned, there's a couple. The offline mode, we didn't really touch too much this semester. We did notice that the previous group's offline mode had some issues. I don't know if some of their stuff is commented out, so we're not sure what works and what doesn't, but if you try to use it now, it's pretty much the maps don't load, so that's like the big thing we need to fix.
And then, yeah, so just mostly bug fixes, maintaining, and then if we have time, just adding any additional features that our sponsor wants. So yeah, are there any questions?
So this is hosted on AWS. So is that from your sponsors AWS accounts that cover all the costs and structure?
Correct. Adventure Cycling is nonprofit, so we kind of have to limit how much we're actually using the server. But it does come from our sponsor, and we do use it to host our application.
They choose the instances for you, or do you get free instance creating and initiating instances?
So we did have a couple issues with that actually at the start of the semester, actually trying to get our servers up and running. But our sponsor has been very helpful and very communicative, and we've been able to ask them for any help, and we are able to create our own instances if we need to. We have a development instance and we have a production instance, so generally we kind of don't touch the production instance unless we're releasing something to it, and then the development one we have a little bit more free reign as far as updating it.
Is this app like very live in this, or are they just still waiting for all this offline?
It's in a beta right now, so it's not released to the public, but we have released it to our sponsor and to the organization and the past team. Really, the previous team had a working version, and now we're updating it. So we kind of constantly get feedback as we release it to the sponsor.
Now, is this a web app or a native application for the phone? And do you see any trade-offs having it on the web application or native application for the phone?
It's a web application that's bundled down and emulated through Cordova as if it were a native app, so it doesn't have all the same advantages of a native application, but it does allow us to have cross-platform a lot easier, so we're just writing JavaScript code. We're not writing Java and then Swift for iOS.
Did you use any tools as a strategy for managing risk?
So typically what we would do is we would, if a risk came upon us, we would document it and we would talk to our sponsor as far as what we wanted to do. So for example, with vector mapping, originally we thought this might take us the entire year to implement. So we kind of brought that up to our sponsor, John, very early on, and we explained to him that this is something that is going to require us to tear out the core functionality of the application as it currently exists, and that might be something that breaks the other things in the application. Fortunately, we were able to salvage the UI and a lot of the functionality as far as adding points onto the map, but yes, we do have a system for risk management.
For the performance issues experience, do you think you can handle it without using the whole design that you had?
Maybe, I guess I'll answer your question this way. Because we're switching to vector mapping, some of those functions that are involved with the performance issues are already being rewritten. It's going to change regardless.
Did you find that having the daily stand-up with the meeting on a frequent basis?
So we do them remotely. I'm sorry if I didn't make that clear.
I know you mentioned that you guys core communication at times where you guys were able to make it.
Right. Yeah. So occasionally, a couple members would miss the online one. So that's one thing we want to work on in the future: is be more responsive and be more communicative.
Let's thank the team.
All right, how's everyone doing? My name is Kevin, and I am a part of the Team Cal Senior Project Team. I'm up here with Aaron, Aziz, and Hussein, and we're working on the Class Cal project for our senior project. So on the agenda for today, we're first going to talk about the product, what exactly the Class Cal piece of software is, how we went about designing and implementing it, and then a little talk about our test plan and verification and validation, things like that. Then we'll dive into the process, how we went about applying Spiral in our team, and what goes along with that, and how we are managing our requirements, some metrics we kept track of throughout the way to make sure we're on track, how we approach risk management, and we'll wrap up with a reflection, what we thought we went well and what didn't went well, and then we'll end off with our plan for the spring term. So we'll dive into the product. The context, our sponsor is the program chair of the School of Film and Animation at RIT here. And he came to us, he's responsible for, creating a department schedule for himself and all of his faculty. So obviously that can be quite burdensome and not that easy. So the goal of our software solution is to build a piece of scheduling software that can make the schedule creation process easier and more enjoyable. Obviously, all of us in this room are familiar with SIS and how painful that can be to do for one person. You can imagine extrapolating that out to making a schedule for 10 to 15 people and how cumbersome that could be. And another piece of software that our sponsor used was iCal, which is just kind of Apple's view on Google Calendar. And you can see trying to schedule a ton of things in a week. Looking at that, you really don't have much idea what's going on in that weekly schedule. You have no idea. So our goal and what makes ClassCal different is that instead of looking at scheduling in terms of kind of dates and times on a calendar, we're going to try and convert that to being rooms and spaces for the department. So on the left here we have the blueprint of the A level of Gannett, which is where all the rooms currently for the School of Film and Animation are. And on the right is our software's kind of interpretation of that floor modeled out. And the way that the software is going to work is the main view of the software is going to be the right diagram there, which is the floor at a given day at a given time. So you're looking at it in terms of what rooms and spaces are available to use or unavailable to use. So obviously when you're making a schedule for a program like School of Film and Animation, some of the rooms have specific power requirements, some of them have specific labs with computers that they need specific software on. So in order to get all those classes scheduled and in a working schedule with co-requisites and things like that, being able to view it in terms of rooms and spaces is the ideal solution we're looking for. So the scope, it was proposed to, I guess, the software engineering department as a two-stage project. We are the first group to work on this. So again, we're going to be working on a single floor in Gannett to handle the current room needs for the School of Film and Animation. Going forward, there's kind of a half stage in between, which includes an easy way to convert floor blueprints and turn them into a floor in our software. And what goes along with that is just adding multiple different floors. So the Magic Spell Studio is currently under construction. That building is going to be containing a lot of new rooms and a lot of things that the School of Film and Animation hopefully will be using. So ideally this product is able to expand and we'll be able to include those new floors that are added with that. And then the last stage is a kind of a 3D building view of the software. So you'll have an outlook on an entire building, and from that view you'll be able to dive deep onto each floor within that building to see the rooms that are available on each floor.
For requirements, the first step we did to gather requirements, we got a list from our sponsor that has all the requirements that the School of Film and Animation are thinking about for the system. Then as a team we sat together to formalize the requirement. After that we sat again with the sponsor. We went over the formalized requirements, making sure that nothing has changed with the list that we got from the sponsor. The second stage is choosing requirements for each spiral. So we choose the requirements for the spiral based on their importance. Then we give each requirement a value from 1 to 13 using Fibonacci sequence. Depends on the difficulty of the requirements. And the last thing is categorizing the requirements in two ways. The first way is back-end and front-end. The second way is related how related is, or what part they are related to the software, such as rooms, classes, or scheduling.
So our main goal with designing the system was, since we are the first team to work on it, we wanted to make it a flexible design for any future teams that work on it. We didn't want to have future teams constrained by our implementation, so we went with the API-powered client application versus the model view template, VDM, MV, whatever patterns. We have a front-end web interface that the client will use to interact with the system, and that web interface receives data from a server-side application. The main trade-off was this, that as a whole, the solution is less cohesive. We're actually deploying 2 different applications, but again, it's more flexible, so if a future team, say, wanted to completely change the front end, then they still have all of our server-side functionality to work with. They don't need to redo all that. Or in another case, maybe they want to expand it with different server-side solution. They still have the front end to work with. They'll require very minimal changes on the front end, on their end to do that. With our implementation, we decided to go with Python and Django on the server. At the beginning of the project, we sat down and considered different server-side web technologies. We knew Python, Ruby, and Java and Node. We were most familiar with Python. There really wasn't anything that frameworks like Rails, Node, or Spring were adding that Django did not provide. Django also is very well documented, and its REST framework is also, again, well documented, comes with a lot of the solutions we need to create a powerful API. There was some performance concerns with Python, but with our context, we decided this was not really significant because Django has the Node to scale to much larger applications. On the front end, we're using the standard HTML, CSS, JavaScript web development tools to build our front end, and we're using Canvas for our graphical solution. That way our users can interact with our front end blueprint. For our database, we went with a PostgreSQL database. We considered the NoSQL approach. We actually went with it in the beginning, but we quickly realized that with our context, a relational database system just makes sense. Our data is relational, and Postgres does hook in very well with Django. It's the first one they'll recommend in their documentation. And in the future, if need be, Postgres does have some NoSQL capabilities. Again, it works very well for us. In terms of more specific implementation, we went with Python 3 over Python 2 because the version of Django we're using, the latest stable version, will be the last to support Python 2. So if any future teams wanted to upgrade the version of Django, they would have to refactor the entire project to be Python 3 if we did it in Python 2 and is using the latest stable version of a language is better future-proofing in general. For verification and validation is done through end of spiral demos and manual tests that confirm business requirements are not being met. So at the end of each of our spirals, we'll sit down with the sponsor, show him our prototype for that spiral, and verify that all the requirements that we brought in for that sprint are being met. We'll also do that internally as a team to test if our product is working on modern web browsers, and to verify, again, test before we show it to our sponsor. Verification is done by the team. During our evaluation, we analyze our implementation for adherence to the architecture for it that we have created. We do a lot of pair programming too, so we verify with each other and keep each other accountable that way with adhering to the architecture. Our testing going forward will include usability tests with other key stakeholders that have been identified in the School of Film and Animation. that are showing a strong interest in this product because, again, the goal is to make a more user-friendly solution to an existing solution. And we'll also be including unit tests in all of our deployments to test each of our API endpoints for the standard use case and also for outlier cases that we may not have considered, may not be common, but are still a risk.
Moving to process, we have spiral model as our process methodology. Spiral consists of 4 phases. The first phase is requirements, where we choose requirements for the current spiral. Then we do risk analysis based on the requirements and any other external effects that we might have during the spiral. Then we move to development and testing, where we develop the requirements we have for the spiral. And the last stage is evaluation, where we evaluate the whole spiral process. Why did we choose a spiral? The first reason is that we're going to have frequent releases, which gives the sponsor a visual view for each thing that we do during the spiral. The second thing is it helps in adding new requirements to the system. And as I mentioned, engaging the sponsor more by giving him visual view of the website. And in case we want to change requirements, spiral is a good way to do that. And the last thing, spiral timing match the semester timing very well, so it helps us to have good period of times for each spiral. For planning, we have 4 to 5 weeks of spirals. The first week is for requirements planning, where we choose the requirements we want to do. The second week is for risk analysis. The third and fourth weeks are for development and testing. And the last one is review or reflection. Sometimes we might have 1 week for both requirements and risk analysis. So we will use the extra week for the development. So it's not always 1 week for each part. The reason we have 4 to 5 week spirals, it depends on the time we're going to need for development. So sometimes we will need only 1 week for development, and other cases we might need 2 weeks. For task estimation, we are using Fibonacci sequence. So we are using 1 to 13. 1 is easy, 13 is very difficult. So it's in this average. Each requirement or task has a value.
For approaching our requirements, as a team we set together, evaluate requirements and gather specific requirements for each iteration, and then we sit again with our sponsor, go over them and validate these requirements. And because we have a good communication with our sponsor, the team was able to add or change any one of these requirements if this requirement is in the scope or meet the business plan. And eventually for part 1, the team met all the requirements. For metrics, so we wanted to keep tracking the percentage of requirements that were changed during the spiral, for each spiral. We choose the requirements volatility as our activity matrix, and earn value chart for our progress matrix, as you see the chart. So set together, evaluate these requirements, assign possible points, and after the spiral, we see if we earn, if we complete them, we earn these points. And to ensure the quality of the application and the performance, such as for how long the software could be run without any crashing, or the number of bugs, we choose mouse clicks per operation for our product quality metrics. And since none of us is a web engineering, but we are software engineers, we always prepare ourselves for risk. So almost a week before any spiral, we sit together, think about the potential risks, come up with a way to prevent these risks or mitigation to help us solving these risks. After that, after the iteration, we check again if the way that we came up with helped us prevent this risk or the mitigations solve these problems.
So move on to our reflection. Overall, we feel our team has been working pretty well together. As we previously mentioned, we broke ourselves up into 2 teams of 2, 2 guys working on the front end and 2 guys working on the back end. It might seem a little strange with such a small team to even break us smaller, but in our opinion, we feel like that allows us to do a few activities. One is like true pair programming with groups of 2. We're able to sit over each other's shoulder and do pair programming. Outside of that, it also allows both individual sides of the application to progress independently of each other, and there's a little bit more risk involved that at the end, the linking of the front end hooking up into our back end API endpoints is going to be risky and not going to work out. But we feel if we document those endpoints well enough, that shouldn't really be a problem. So the second bullet point, our startup was a little tough. Obviously, we've all had co-ops before. None of us have really used the spiral methodology or followed it rigorously. So our startup was tough into what we needed to be tracking, what kind of documents we needed to maintain, and things like that. We feel like we've kind of found our footing here. We are currently on spiral number 3. I'm about to wrap that up. So the first 1 or 2 spirals, our process may have not been followed as rigorously as it should have been, but we feel like we found our footing, and going forward we should be doing a better job at that. And lastly, we feel like our development pace has been sufficient enough to get us to complete this project by the end of the spring term. Our first 2 spirals ended up with deliverables of static prototypes, just to make sure ours and our sponsor's vision on the UI and the UI elements was relatively similar and things like that. And as we wrap up our 3rd spiral here, that'll be our first deliverable that is a functioning web application. So we feel like we're at a pretty good point going forward. And on that same topic, for next term, as I said, we're going to continue with our current pace with 2 5-week spirals and 1 4-week spiral, ideally. Spiral number 4 is going to be the first 5 weeks of the spring semester. Ideally, there's a few architecturally significant requirements out there left to complete that require a very high level of interaction between the back-end and the front-end teams, and ideally those can get knocked out, and then after that, any database schema changes are done, everything's set up perfectly, we don't have to worry too much about that going forward, which would lead us into our spiral number 5, which is another 5-week one. That should basically be any major pieces of functionality. As I said, the data shouldn't change much. It might just be a few new ways of presenting that data to the user and a few other things like that. And then our last one is going to be a 4-week spiral at the end of the spring semester, which ideally is just going to be polishing up some UI elements, making sure we didn't forget anything key that's going to make the sponsor unhappy and things like that. So does anyone have any questions? Sure.
All right. You mentioned concerns about integration between the front end and back end, separate teams, and how that might be a risk to clean up. Have you practiced continuous integration and trying to mitigate that risk?
So since our first 2 spirals were static, we have not tested that yet. We are integrating at the end of each spiral, though, but to do that on like a weekly basis, like during a requirements week or during a risk analysis week, it may be hard to it may be hard to formally put that in, but ideally we are deploying our API enough that it can that new endpoints can be hooked into the front end on a pretty frequent basis, as opposed to big bang deployments. So we don't have to do everything at the end. We actually to kind of solve this issue, we are using a facade between the 2, so that that interaction between them is simplified even further through that. Does that answer your question?
Yes.
Okay. Yes.
You guys mentioned that you've never used the spiral methodology before. Why were some of the reasons that you chose that over one that you used?
So our The biggest appeal of Spiral was well, one, it was iterative. We wanted an iterative process because our requirements were not set in stone. We wanted to be open to change. We wanted to be able to give continual feedback. And two, we liked Spiral's emphasis on risk. We really believed that was important for our process to have that. We had considered Scrum, but we didn't really feel that was appropriate since our schedules, we couldn't meet in person as much as Scrum we felt would require. We also considered evolutionary delivery, but the trade-off for that was it implies a lot of concrete requirements in the beginning and then just continue building off those requirements. We wanted to be more open to change. We believed evolutionary delivery allowed us to be. So that's, in the end, we ended up with Spiral.
You mentioned earlier that you're going to try to develop some technology, so-called mapping, so where you can turn it into a database like a representation. Are you allowed to do that, or what's the progress on that?
So that's kind of, it's slightly out of scope. It's a little bit of a, it's possible that we would have in some future implementation of software like the ability to import, let's say like CSV files that are vectors, and then you draw the rooms based off a CSV file. For us, we just currently did the one floor that we needed to get done for our section by hand, where we went through and hand drew the vectors and hand placed them and things like that. So ideally going forward, there'd be some sort of process to make that easier than doing it all by hand. But currently, I think that's out of our scope.
It seems that a lot of your process is focused on risk. Are you using a risk management tool to track those risks?
We currently just have an Excel spreadsheet that is risks and exposure and things like that, and we're using that. And then we have a risk backlog for anything that are risks that have either become realized or passed or things like that. So those two things together would be how we're managing that.
Like any tool related to would not be like a, I don't know, like a software to specifically track with, but I guess would be a tool brought in as a mitigation strategy. So that's the only tool I'm going to use. Yes.
For your last Spiral, you mentioned polishing. I didn't see anything about deployment. Is this being deployed on RIT servers by chance for the film and animation department? And if so, what risk do you see in that?
So one of our biggest risks was how we're deploying this. We aren't actually provided with an environment. We'd considered hosting on cloud, but we don't really have any way to cover costs of cloud deployment. And if we did open up an account, we'd have to pass all that account information between teams. So that can get muddy. We didn't really have a credit card to put down for AWS, for instance. So we're currently hosting it on an SE VM. Now that's the best viable solution for us. We also considered RIT's web environment, but as far as I understand, that supports PHP, and we're pretty limited to that, and we didn't want to go the PHP approach to the project. So that's how we're hosting it right now.
I have a question about the functionality itself that you plan to implement. You said in the future you wanted to be able to add more floor plans. Was that by scanning in like a floor plan diagram, or was that by going in and having UI to like manually create the floor?
Again, that's kind of out of the scope of our domain. Whether it is a piece of software that can read some floor plan image and convert it to a building, or it's read that image and convert it to like a CSV file that has the vector endpoints to draw the rooms or something like that. We haven't thought too much onto that, but yeah.
So there's a few things, stage 1.5 and 1 and 2, that are out of scope clearly from what you originally wanted to do. Have you taken any specific steps to mitigate the problem of refactoring your code in the future?
Yeah, the most we did for that was, again, making sure that what our app can be extended in different ways. Again, that's why we separated the front end and the back end, so another team can get rid of one and keep another. But we don't really have any built-in tech. I guess we don't really have any built-in tech constraints because we wanted to make sure that our app was modular enough so that if it were necessary to say, make a new UI solution, that they could do that and still hook in to our back end, at them being two separate apps.
Yeah, and I'm not sure if it wasn't clear, but the scope slide, stage 1.5 and stage 2 are totally out of scope for us as a team. Like, we are strictly worried about stage 1. Like, that is our scoped area. So stage 1.5 and 2 are just kind of what our sponsor mentioned, his proposal going forward, what he would like to see going forward, and just a basic idea of how we would implement that. But we are strictly worried about stage 1.
Yeah, for instance, for stage 2, setting up some sort of OpenGL start, something is out of scope for us. That would have to be completely started by whoever takes on stage 2.
Let's thank the team.
For Madness, and I am Jake.
I'm James.
I'm Hui.
And I'm Mitchell.
So Carrier Transit Cold is a company that manufactures refrigeration units for reefers. A reefer is a short word for refrigerated container. A refrigerated container is about 8 feet wide, 9 feet tall, and can be up to 45 feet in depth, as pictured there in red. These containers can hold up to $1 million worth of cargo, and they are stacked on top of one another and transported on giant cargo ships, typically overseas, or they could also be transported on tractor trailers as well. So Carrier Transit Cold's job is to maintain the proper temperature and humidity of everything inside the container. There are more than 100 sensors inside each container, and reefer technicians, as pictured here on the bottom right, often have to connect to the reefer container directly over a USB serial connection, and they do that to troubleshoot data, like sensor problems going on inside the container. Carrier Transit Cold is currently working on adding Wi-Fi capabilities to the container so that the technicians do not have to physically connect. So Carrier is asking us to build a cross-platform mobile app that will be able to connect to the reefer over Wi-Fi to allow the technicians to troubleshoot and monitor sensor data in real time. Our app has to perform advanced graphing, allow the technicians to view any active alerts, and also export data in a CSV format. Some of the big implicit requirements given to us by our sponsor are ease of maintainability and usability. In our first project sponsor kickoff meeting, most of the requirements were given to us in a nice, neat, categorized format, but of course we didn't really understand them that well, so we spent our first couple of weeks reading over the Carrier documentation and asking questions of the Carrier team. And then we mapped all of the requirements that were given to us into our own internal requirements document, and throughout the entire duration of the project, we referred to the requirement codes in a Trello board to manage our requirements, track who's working on them, and when they are due. So I'm going to go over some unique risks that we encountered and how we chose to mitigate them. The first big risk was very clear very early on. This was something that Carrier had explained to us. They were actively developing the Wi-Fi connection system that would work in their reefer containers, and that basically represents 1/2 of the communication system that our mobile app will have to use as well. So this actually informed how we chose our process methodology. We chose to do design to schedule because it meant that we could basically schedule out our work and work in parallel with Carrier and ensure that we could get as much done in tandem with them getting work done as well. A second big risk was that using their proprietary communication protocol might end up being really difficult. We were a little worried that it would bog down a certain portion of our time developing the project just because of, let's say, a lack of documentation or examples or a misuse by us. So actually this was mitigated by Carrier. They gave us a ton of documentation on it and a lot of examples, and that was great. We also assigned a team member, Mitch, to basically act as someone that learned an extra amount about the documentation so that when we get to the point of developing using their protocol, we can dive right in quickly. The next two risks are technology-based, and Mitch will go over this in more detail in a later slide, but to touch on them quickly, we wanted to develop the app in React Native at first, and we quickly became worried that both of these things might come true. The first being that a Windows app would be more difficult to complete than an iOS and Android app because there's no actual built-in direct functionality for writing a Windows app in React Native. And a lot of the engineers use Windows tablets, so it was important that we get that right. The second one was that we may have to develop significant portions of the app using built-in programming languages that are in each device. And both of these came true, and after a certain amount of research, we opted to change our technology stack and switch to Ionic. And finally, we were worried that development for multiple platforms would just mean a really rigorous and complex QA environment, testing environment, where we'd have to be redeploying to multiple platforms and making sure that it worked correctly. To mitigate this, we're just all using the same environment, and we actively push to all three platforms weekly to make sure that everything is up to date and working correctly.
So to go a little more in depth about our process methodology, so we chose design to schedule for a number of reasons. The primary one that James went over being that we're working in parallel with the Carrier team, and so this, and in addition, in our initial requirements, we had a lot of stretch goals that were included, and so what this lets us do, this lets us design our high-level architecture design at the beginning, but delay detailed design of different subsystems until we have a clearer picture of how that's going to work, especially the connection with the reefer. And in addition, it allows us to plan our architecture to be expandable for all of our stretch goals, while in addition not necessarily providing that they're going to be in scope for our portion of the project. We just have it in case we were able to move faster than we anticipated. We were able to incorporate these extra deliverables, and if not, they were out of scope to begin with. So in the first semester we had our first three deliverables. As you can see, the first one being UI and architectural design, which included our high-level architectural design as well as wireframes. And then we spent a lot of our next two deliverables were UI. And the reason we did this is it let us delay our connection to next semester so that we have a much clearer picture about how that's going to work. And then obviously we will reevaluate the schedule going into next semester and then continue along with our deliverables. So technical decisions. So as mentioned, we initially wanted to go with React Native. We were kind of naive, and we were like, oh, this is such a cool technology, and it's going to be exactly what we need. And as we started to look into it and try and match up our requirements and what we were going to need to do, we quickly realized that some parts of it just weren't going to work with what we needed to do. As mentioned, React Native, to compile down to Windows, it's a third-party plugin, which is provided by Microsoft, but it's not built into React Native itself. And in addition, because of this, there are a lot of things that might be supported, that might support React Native, might not support React Native when it's built to Windows. So because of this, a couple weeks into the semester, we had to reevaluate. We looked at a couple different options. We looked at Xamarin, we looked at Ionic, and we ended up going with Ionic, which is a web-based solution which compiles down to a native app, essentially. Uses the browser renderer to display a web page. So it has much better support for Windows. We already had some experience with Ionic, and has large community support. So some of the trade-offs, not being a native app means that there are some performance issues that could arise. And so that was something we had to look at, and we determined that because of a lot of our app is just data display, we weren't going to have any performance issues in using native functionality that we'd have to tie into. And then on top of that, we're using an ORM layer on top of our SQL, which is a little more heavy than just raw SQL, but it allows us to handle the objects a lot cleaner and develop a lot faster. So this is a high-level picture of the architectural design. So most of the app is data display of various forms. So obviously we have the database, and we have a component to aggregate the data and allow us to interact with the database. So as you can see, the reefer connection is bringing data in, and then the other three main components, which is data visualization, which is graphing, data display, which is just raw data display of numbers, and then miscellaneous, such as exporting the raw data in CSVs, all use the data aggregation.
Okay, so I'm going to go over some of the metrics we chose. The first was defect density. This was it's a classic metric, obviously, and it's just a good representation of what hasn't been done that needs to get done at any given time, especially if we're approaching the end of a deliverable. So we use GitHub issues to track this. These are just internal defects within the application. And yeah, we're currently sitting at 0.73 defect density. We've written 4,000 lines of code, and we have 3 open defects as of right now. We also keep track of unit test code coverage, and we have a visual for that. We will go into that in more detail later, so I won't touch on that now. For our process metrics, we chose average time to fix per defect. This ties in with GitHub issues, being able to do it very quickly, and ensuring that we're prioritizing fixing bugs, or at least not letting that fall behind in our schedule. Right now, we average 1 week to close issues, but that's a somewhat inflated metric because of Thanksgiving break, and because recently we've had to focus more on the presentation and some of the more meta aspects of the senior project. Before that, our average rate was closer to about 2 days. And finally, we have a schedule slippage chart, and as of right now, the only major schedule change we've had was 1 week pushback for deliverable 2, which was the basic UI, and that pushed back the deliverable 3 as well. But we're pretty confident that going into next semester, we'll hit deliverable 4 at the expected schedule date.
So I'm going to talk about the testing strategy. So the main core of the application are dependent on other libraries, which are maintained and tested by well-known group or established company. So sometimes writing unit test would be redundant. In many cases, for instance, we use type ORM for the database management. So to write the unit test for creating database, creating entity, are unnecessary. And for that reason, as you can see here, we don't have a lot of we have low test coverage on database module, and we allocate our team resources on the user acceptance testing, where we have more releases, so we can have more feedback from the user, and so we can and we can identify any problem quickly. So, and this is another representation of so since the first release until now we have about 19 issues, and 85% of the issue will close within 1 or 2 days. And as James mentioned, we have about 3 open issues.
So to be more specific about the progress we've made this semester, the first thing we started out with was detailed wireframes. We used Adobe Experience Design to create wireframes for each and every screen of the application. Then after that, we moved into the database schema and high-level architecture design. And we now have a fully functional, we have all the UI functionality done on iOS, Android, and Windows. And our customer is satisfied with the UI design decisions that we've made thus far.
So some future plans going into next semester. We're going to, obviously, as we get into those deliverables, we'll do detailed design of the back-end functionality. And then the big one is connection between our app and the reefer over Wi-Fi so that we can actually pull actual sensor data as opposed to the mock data that's being used by the UI right now. And then, obviously, if we get there, we have the stretch goals of the 2 different deliverables, which allow connection to multiple reefers at the same time, and also monitoring of specific maintenance tests that the operators will run before a trip to make sure that each and every container is able to, heat up and cool off at the appropriate timelines and things like that.
So now we have a demo for you. This is going to be running on a Pixel 2, the latest Android software. This is the landing page, and you click the dashboard button to see all of the sensors of the reefer that you're currently connected to. This is just mock data right now, but you can see that we have 4 rows here of various sensor types. If you click a sensor, you could remove the sensor from the row, and it will readjust the size of the sensor boxes. This page shows all of the sensors of the reefer. If you pull left, you could favorite sensors so that you could see them more easily on the dashboard page. So we just added a sensor to row 2, and now it popped up right there again. Now we're going to add another sensor down to row 4, I believe, just to give you an idea how this works. This is what the technicians would be doing. They'd be loading up their favorite sensors or the ones that they believe are causing the issues. Now we're going to demonstrate switching from Fahrenheit or Celsius to Fahrenheit. So we go into the settings page here. We can toggle between units. Right now we just have Celsius and Fahrenheit. And if we go back to the dashboard, you'll see that all of the temperature sensors are now reading in Fahrenheit. We also have alert functionality, so the reefer will have some alerts going off if some sensors are displaying some bad data or if they're broken or anything. This data is not real data right now, but it is reading from the database. This is our CSV export page. You can export data from selected sensors. And we are still currently working on the graphing functionality, but I figured I'd put this in the demo just to show you guys what we're working on. That's pretty much all the functionality that we have right now. And this is Android, but it does work on iOS and Windows. Take my word for it.
And the one thing to note about this demo is when we initially went to the dashboard, you may have noticed it took a long time. The loading text was up there for a while, and the reason for that is the way the data is mocked right now, we're getting new data every 5 seconds, but that includes for the initial data. So the app is all loaded. It's just waiting for the database to initially get some test data so that it can read it.
Well, in any case, it's just questions now. Let's see. There we go. Let me present that. All right, any questions? Yes. Yeah, you. Yeah.
So you have a wide range of devices that you have to support for this. Do you actually have physical devices to test all those on, or how are you handling that?
We don't have a physical Windows device. We have physical devices for the other 2. But the simulator works well for simulating all 3.
And in terms of that, for Windows, we don't have a tablet But the way this builds is going to build down to a Windows Universal App, so we can run it on a laptop and such. We just might not have, we don't have the touch controls that we could go over. We'd have to input that with a mouse.
You have support multiple devices, so you kind of consider natives and every phone technology like Ionic and React Native and all this. Do you also consider using HTML to create the application, or are you not able to do that?
So this is basically HTML and JavaScript. So
Yes, so that's Ionic.
so Ionic should be on top of Angular, and Angular using JavaScript and native HTML. So
You mean just using HTML?
That would be.
We genuinely didn't
We
consider
did
that.
talk. No, we talked about it.
Okay.
But we felt that having it as an application on the
I
phone rather than
misunderstood. I didn't see it.
as a web page would be. So the way the technology works for the connection to an individual reefer, they can either connect to an individual reefer, which will act as a hotspot on its own, or they can connect to a reefer over a network that the reefer has been connected to. And so because of that, it was much cleaner for us to implement that just as an app that's going to run on the phone. It doesn't matter how you're what network you're connected to or things like that.
And to touch on that, because we have to use some form of custom protocol to from the phone to the reefer. So it's very hard to create that protocol on the web-based application. So we have to somehow use the native side of the mobile app to create the connection.
Mm-hmm. Yeah, in the back behind you. It is in the first.
What was your UI design process like? How did you make your UI design decision?
Some of it was informed actually from some design concepts that Carrier themselves had. And initially our UI was actually a lot more like that. And then other design choices were actually informed by Ionic and what was best for how Ionic likes to implement views, buttons, layouts, etc. Yeah.
Your demo, you guys use the latest Android OS. So my question is, have you considered
We work back to.
So our application is supported back to Android 6.
Yeah.
However, the way our requirements were written was that we could support just the latest for all of the different devices. But obviously, the way Android works, a lot of devices don't run 8 yet. But we're not using any functionality in Android 8 that isn't available in previous versions. So I'm pretty sure our app is compatible back to Android 6. Yeah. Yes.
I might have missed this, but in case you're not getting the data that you expected, how would you have show what is going to be actually shown?
So the way the design is going to handle that is there's going to be an indicator if the data is out of date. So after a certain amount of time, certain sensors, if you haven't received any data, that will be shown on the UI. And in addition, if a sensor is not getting any data at all, like we're receiving the data, but it's not, the sensor's broken or such, we're going to be getting a value that's out of range of the sensor. And so that would be something where we would display, for each sensor we would know that this is the default out of range value if the sensor on the actual device is broken, and we would display that.
Okay.
Let's thank the team.
Cool. Hi guys, we are Team Alpha Helix. My name is Ben.
I'm Aaron. I'm Gavin.
Cool, and we worked on the generic online annotation tool called GOAT. So we're just going to go over kind of the context for what this application is, who our sponsor is, and what kind of the application's about. We're going to go over the status of the project as we have it now, and some of our future plans. Then we're going to go into kind of our process and how we developed the application and some of our experiences that we had while developing. Our sponsor is Phoenix Bioinformatics. They are a nonprofit, and they basically focus on something called biocuration, which is where researchers will extract data from publications about biological information, and they basically will make these things called annotations, which are basically this kind of grouping of information that says that a gene is in this location in the cell, or this gene has this function, or this protein interacts in this way, kind of. And the whole goal is to effectively build, or the whole system, how it currently works, rather, is they have this thing called TOAST, and it's effectively how these researchers will implement or enter in all of this kind of very complex information. It's 7 years old. It's not that user-friendly, and in order for the data that researchers enter into the system, Phoenix has to review kind of each of the annotations, and that process is entirely separated from the submission platform. And so basically, we wanted to make this kind of combined system where researchers will be able to input all of the annotation data, so all the genetic information. Phoenix Bioinformatics will be able to curate each of the annotations to make sure that there's no typos and that they're choosing the correct, what are called ontologies for each of describing the genes. And then we'll be able to export all the data into a common format that will be able to allow the data to be used by other databases and kind of sync across everything. And so the previous team, this is a second kind of phase thing, the previous team really worked on kind of sort of the data input and the database side of things, and our whole team was to build the rest of this kind of picture.
So as Ben mentioned, this is a second year project. The team last year was Team Blue Jeans. They did most of their work on the database and the back end components of this system. On the right side of the screen there is the database model, the schema as they left it at the end of last year. We've made some small changes to it since we picked up the project, but most of our work this semester has been in the front end. For their part though, they did fully customized front end layouts towards the end of their work last year, and they also set up a very detailed wiki and installation steps on their GitHub boards. But our work so far, we overhauled pretty much all of the front end work that the previous team did. It was fully customized, as I mentioned, but we decided to replace it with Bootstrap to make it a little bit easier to scale and edit. We expanded the back end to support new features, specifically a new data field called evidence with, which is just another relationship between genes and other genes. We added additional submission requirements, specifically a preview page before submitting, so that researchers can look at their submission and make sure all of the information that they're submitting is correct, make sure that they don't have any typos on their own. So it adds a little bit of curation to the researcher side, making sure that they can see that everything is right to their knowledge before it goes along to the curators. We added the basic curation functionality. This was one of our later requirements for this semester, and it's going to be continued in the next semester. But the basic curation that we have right now, you're able to pull up these submissions from the researchers and review each individual annotation. And we also added a data export in one of the two required formats for data export for the initial requirements, which is able to take all of the submissions in the database and export them in a common format, the GAF format, the gene annotation format.
Something like that. The Go annotation.
Yeah, the Go annotation format, my mistake.
Cool.
So some of the technologies we used, we pretty much the entire system is written in JavaScript. In the back end, we have Node and Express. We're running a Postgres database. We have React and Redux for the front end, and as I mentioned, we implemented Bootstrap for CSS this semester. And we also have Chai and Mocha in the back end for testing. Most of that came from BlueJeans as well. They set up most of the existing testing framework in the back end, and we'll talk a little bit more about that in a later slide. And then we're using Bookshelf for our ORM in the database. So this is the layout of the submission screen as we received it at the beginning of the year. This is the final front-end state as we received it from BlueJeans. You can see there's the publications being referenced, place to input genes, and after a gene is inputted, you can add annotations about it. And that leads into this, which is our current front-end state. We still have the publication, a little bit more information about it. It will pull the data for the publication that you're referencing. We have the gene input box. It automatically validates so that when you input a gene, it will automatically spawn an annotation to be edited. And there's reset functionality. So we have a demo here.
So this is a quick demo. We have our home page here, and at the top there's submission and curation portals. And based on the user's role, they will either be a submitter or a curator, and they'll be able to either submit or curate, or both, potentially. So the first process is entering a publication, which gets validated on input, and it loads the title and the author of the publication to confirm that you have the correct publication you're looking for. The next step in the submission process is for the researcher to enter the locus and genes that they're working with. And once those are loaded, you can create the annotations that you want to create for the publication. There's different types of annotations that have different formats with different information being pulled back, and for some formats evidence width is required, and you can see there that for those formats the researchers are prompted to enter the evidence width for the annotation that they're creating. And once the researcher has entered their annotations, they can review their submission to check that it's what they want to submit. They can also view more details of the things they're submitting, and go back and make changes if necessary. For example, if they got the order of their protein interaction wrong for some reason, they could fix that, and then they could decide it's good to submit. And if they wanted to, they could go ahead and make another submission. So it's a quick process, which makes it easy for researchers to make these submissions. As a curator, you can review submitted submissions and make changes as a curator. So curators make sure that the data that's being input is in a good format, and it's the annotations are of quality standards, and they have the ability to approve or reject annotations made. And so once the curator goes through this process of reviewing annotations, they can save their changes, or and also preview their changes that they're making. And so a curator will be able to save their curation in progress and come back to it later if there's a whole bunch of annotations made within a single submission. And when they come back to it, they can pick up where they left off and make any more changes that are required. So they could decide they want to actually reject an annotation or change it some more and further curate the submission. And when they're all done reviewing their changes, they can finish curating a submission. And it will show up in the reviewed section. So our process revolved around a modified version of Scrum. We basically talked with our sponsor and decided what requirements we should be working on for each sprint. We did 2-week sprints, and we used Planning Poker to decide how difficult the items we're working with would be. So one of the problems we had with our process was our stories were too large. So we ended up having these gigantic stories that some of which spanned across the sprints. So that's a thing that we will be improving for next semester. We used GitHub projects to track our sprint backlog and status of each of the user stories. And yeah, we used Slack to communicate So as a result of our gigantic user stories, you can see from our burn down chart that the user stories weren't technically completed until the end for most of them. So going forward, we will be using much more granular user stories so that it's more useful. Our test cases also have been a good percentage of passing. These are mainly for the back end.
So on the topic of testing, one of the things that we got to do, which was sort of unique to the testing for this project, is we had really frequent user testing. As we finished deliverables and made UI updates and we were able to deploy to Phoenix, they were able to take the changes that we had made and test them themselves or take them out to potential future users and other researchers to get real-time feedback on whether the changes were helpful, whether or not the system was easy to figure out, defects that they found during testing, and we were able to get a lot of improvement suggestions from these user tests, which we would integrate into the sprint that we received the feedback and deliver upon them for the next sprint and the next user test. Besides that, as we've mentioned, we had most of our tests in the back end. They came from the previous team. We added some user tests and we fixed some broken user tests that we were left with, which is why our testing percentage kind of shot up at the beginning and stayed static and then dropped again towards the end as we started working on the back end in our last sprint. And during that last sprint, we used test-driven development, writing tests before we implemented features.
Cool. So we're going to talk a little bit about what went well and what didn't. Getting all of the rapid user feedback, you can see some examples of some of the feedback that we had our sponsor type up. There was a good portion in the middle of the project where we were pretty much rapidly changing where buttons were, how stuff was laid out, what was available when, and all these kind of really core user features. And we were basically able to get that quick turnaround, which was really great. The testing was a lot of fun. We used that kind of, like, once you had the project all working and we could fully curate and do everything that the sponsor wanted, it was actually, you know, kind of fun to get everything, all the tests and everything going. So, we delivered our full MVP. So we were kind of pushed at the end there. We run into some unforeseen problems, but we were basically able to push through and get the final thing that we wanted delivered. And finally, I think we had pretty great communication with our sponsor and our faculty coach and everything throughout the process. We faced some issues. There was some problems with scheduling time to meet. We could only really meet as a team really in the evenings, and that led to some kind of late nights, which we want to change in the future. There was a long onboarding process, so trying to understand the past team's code and also learning React and Redux at the same time was pretty difficult, and it delayed a lot of our initial sprint goals and a lot of the things that we wanted. It really took a while for us to really be very productive in this system. And yeah, like we mentioned earlier, the stories were too large, and we kind of underestimated how much time it would take to do each of them, and so we kind of had these large things that were just carrying, you know, between each of our things, even though they were all being worked on pretty much all the time. And just kind of a division of labor, which we kind of ran into by accident through the project.
So plans for the spring, continued UI improvements is kind of one of the major goals of the project, as stated by Phoenix, is they want this to be, you know, easy to use, easy to navigate, and you know, it's a volunteer process, so it needs to be, you know, friendly for people to access, especially if they're not, you know, if they didn't commonly do it on the old system. We have some additional data sources that we want to add for the annotations. One that comes to mind is there is a chemical database called Chevy, which is another external source that we can connect to add information to the annotations. We need searching and browsing functionality of reviewed annotations. So after the curation is done, we want users to be able to look through and see all of the annotations in our system. We want to be able to save in-progress submissions, since these can get pretty long, as we've alluded to. We want to be able to, not just for the curators like we have now, but for the submitters, if they're working on a submission that is very large, they can save it and come back to it at a better time. And we have another file format that we want to support with data export and make some general stability and reliability updates. One of the major issues on that front is some of the external databases can kind of flake out sometimes during testing. It is something that we didn't really address in our testing coverage numbers, but sometimes we would have failing tests just because the databases weren't responding, even though the functionality was working fine. So we want to work on that. And
yeah, I guess basically we're going to adjust our process to kind of fit some of these issues that we faced over the time. We're going to estimate more time for each of our things. I think now that we have a better idea of what we're working with and some of the technologies that this will help. And yeah, really taking full consideration of each of what's required for each story as we go. So, questions? Yeah.
So you said that you wanted to manage expectations more. Do you think you would finish your minimum viable product if you manage your customers' expectations with less hours worked? Considering you guys look like you worked about 20 hours per week?
Yes, we want to manage expectations more so that we can achieve the MVP for the next semester with fewer hours worked.
How did you track and manage risk?
So we used just the 4-ups pretty much, and we every 2 weeks when we had our kind of our sprint meetings, we would just go over kind of some of the risks that we were facing or kind of things that we were dealing with, and a lot of that was just kind of being upfront and honest with them about onboarding and learning the existing technology and kind of going with that. So
as the sprints rolled along and we kind of became more focused on, you know, iterating on the feedback and things like that. So the early weeks we had a lot of discussions about how to manage risk, how to handle the onboarding and the domain context. But as we rolled along and sort of had a better understanding of what we were doing, we focused on it a little less, so we could focus a little more on iterating on the feedback that we received.
So you guys decided to use Redux with React. Is that something our team looked into? I'm just curious why you decided to use Redux rather than just normal React.
So we inherited kind of their existing Redux code that they had written for the system. However, through working with it, we noticed that it wasn't really organized the way that like Redux kind of like best practices would dictate. And so we actually did wind up spending a lot of time refactoring that and changing it so that it would be kind of more updatable in the future and more maintainable. But yeah, basically it was just Redux helped us maintain the React state, and we inherited it kind of from that. So.
So are you guys probably using a lot more corporate bootstrap into it, or bootstrap based most of its responsiveness? What was that a feature set response, or one of your goals would have more of a aesthetic choice?
There's the future goal of supporting the application for tablets. So that's something we intend to do by making use of Bootstrap's responsiveness. But it was not something for the MVP for this semester.
It was really just because we couldn't change the UI the way we wanted to with the old setup, and we were all pretty familiar with Bootstrap, and so by changing to that allowed us to build kind of those reusable components a lot better.
This may not have been fully communicated during the Blue Jeans section, but the fully custom front end was just handwritten CS code by one of the Blue Jeans members, just completely customized from scratch. So being able to edit code that we hadn't done any work with their CSS before, it was easier to replace it and work with something familiar.
So a lot of our communication was just pretty much kept on Slack. It was kind of, I guess, a continuous sort of whenever there was an issue or whenever we needed to deal with stuff. So we did not explicitly do stand-ups, but we are looking into ways to improve our process for next semester to help us kind of be more all on the same page. So yeah, we're looking into it.
Despite the late meeting times, we did do a lot of in-person meeting, which kind of mitigated having to communicate stand-ups and through Slack. So we would have, up to 5 meetings in a week, just for at least an hour or a couple of hours to work on things together or discuss what needed to be done, work on documentation.
Oh, yeah, a lot of our work was co-located, and because of that, we felt that was the best way that we could all focus and work on the project. So that's kind of how we wound up.
Let's thank the team.
Okay, so we're our final presentation, but it's going to be a fun one. So we have game room recruiting, and my name's Dominic Cecilio. I'm Alan.
Steve Colsa.
Daniel Roach.
So to give a little bit of context about our project mission, we were sponsored by Jim Bondi. A little bit of background about Jim: he works in the RIT Career Services. So he interacts a lot with employers and students. One of the problem statements that he made that really resonated with me was, we're interested in companies that will recruit RIT majors but don't come to campus. Now as SE majors, that's kind of hard to take in, right? We get pampered a little bit, we get heavily recruited by tech companies, they'll come to the career fairs. Other majors such as medical illustration majors, 3D imaging, some of those majors don't get companies coming to RIT as much. So what we're trying to do is provide a platform that's going to connect interviewers and interviewees. And what we're trying to overcome is the experience that you usually get from Skype. With Skype, sometimes you miss out on the interaction of the person, so you focus on a video stream. Sometimes that person might be focused on another monitor. You don't really feel like you're in the same room, as right now we're all in the same room. You can feel my presence in the room, and we're going to address what we mean by presence as well. So what we're going to try to do is emulate an in-person interview as closely as possible.
So basically what we're trying to create here is a remote interview system that is based in a virtual reality environment. So as he said, to try to recreate the feeling of presence that you would get from an in-person interview. Since a lot of technology we're working with here is still not fully developed and not fully open for public access, we've decided that augmented reality and mixed reality are out of scope for this project.
So now for requirements. So our requirements are mapped into epics, of which we have 4 major epics, and then we have other minor epics that may emerge as the project progresses further. The first one being a game room environment, and that entails the work needed to set up and configure a game room. The second one being screen sharing, which involves taking a user's camera feed and being able to share it. The third one being video stream, and that involves applying a chroma keying technique we'll go into later. And the last one being immersive background, where we actually put our user into the VR environment and create an immersive background.
So for process methodology, this was an interesting aspect for our project because we did have different experiences with processes. Some of our team members had startup experience and not a lot of experience in big companies or enterprise companies where you might be heavily driven by process. So we wanted to introduce a methodology that wouldn't necessarily make it complex to get work done. We ended up using Kanban. Now, some of the advantages of using Kanban was that it encourages communication across the whole team. One of the reasons why it does this is you have a flow, basically. It goes from left to right. So you might have a story that comes into selected for development. The developer picks it up and it goes to in progress. Then once that developer feels like it's been done, he puts it in a ready for acceptance stage and then reviews it with another team member, and then it will follow into the done stage. So one thing this does is it reacts well to an environment with a high degree of variability. Since we do have a lot of experimental technologies, we do feel like requirements are changing at times. We didn't want to be fixed to sprints, so we didn't want to have a 2-week sprint where we might feel like another user story is more important, or we review it with our sponsor and they feel like something else is important. With Kanban, you can always focus on customer-centric requirements or user stories in our case. And another important thing about this is, we'll get into metrics later, but you can balance demand versus throughput. So what does that mean? Sometimes in co-ops or at companies, you have a product team, and product teams want X amount done. And developers can only get a certain amount done. So this is our throughput. We're going to talk about throughput a little bit later on, but with Kanban, you can track some of these metrics and come to a consensus with your sponsor as well in terms of how much work you can get done over a certain period of time.
So now for architecture. So the entry point into game room recruiting will be a web application. So that'll handle user sign-on, creating accounts, adding contacts, sending invites to game rooms, and more. So it's really just the administrative functionality needed to set up and configure the game room. So once all that is said and done, we're going to use A-Frame or VR technology to put our users into the game room itself.
Okay, so one of our main portions of our product is this video streaming in VR. And so we looked into what can do this, and we came up with a WebRTC, which is just a web API open to all browsers. And we are going to, in order for this to work, we need to set up a secure network, like using HTTPS. And we also have to have stun and turn servers, which allow us to create this direct connection between two browsers instead of having to go through like one of our own servers and then give that over there, because video data is a lot of bandwidth, and so it would be best if we can just go directly from one person to the other person. And the whole, the thing about WebRTC is that like it punches a hole in your firewall that allows this direct communication.
Another important part of the application was getting this feeling of presence. So how we wanted to do this was using a green screen and performing a chroma key algorithm. So what this basically does is it gets the video feed. So from WebRTC, it sends the stream data to the video parsing module. We ended up deciding to use a web worker just because JavaScript is single-threaded. So in case we ran into performance issues, we wanted to have multi-threading implemented. So what it would do is video parsing module gets the video data, sends it to your web worker. Your web worker does the chroma keying, which would be removing the green pixel, sends it back to your video parsing module, and that repaints it back on the VR canvas.
So when we were discussing what we're going to do to create this application, one of the main things that we're talking about is VR here. It's like, how are we going to create VR? And a lot of VR applications out there right now are just software games, and they use Unity and Unreal. And so we looked into Unity and Unreal and found that the ramp-up time for us to learn those technologies would cost a lot compared to technologies we already are comfortable with, such as web development. And also deploying and configuring for different applications or different devices, such as like Android, iOS, whatever, that takes a lot of time as well. So we decided to look into web VR, which the team had we're somewhat familiar with. And WebVR allows us to touch a whole bunch of different devices, as well as it's easily plug and play with a whole bunch of different VR devices as well. So we can export to iOS, Android, any device you want immediately and get this. The only issue is the trade-off would be that it's less performant. But in our situation, we're not trying to be like super graphical. We're just trying to get this video to video feed. So we thought this was the best solution.
So we have a detailed risk document with the probability, impact, and exposure of all of our risks. And so based on that data, these were some that really came up. So we have visibility for our sponsor. So we set up Jira for transparency with our workflow. And our sponsor actually wanted to be very hands-on with the technology that we're working with. So we took steps to educate our sponsor on all the technologies that we looked into. As I said before, since some of the technology we're working with is still not fully in development, or still not fully developed or open for public access, we had to design some alternate solutions using what's available right now.
So backtracking a little bit regarding the metrics, some of the metrics that we decided to go with was cycle time. So cycle time is the time it takes for a task to travel from development to being done. So what this helps us with is planning features. So for example, if you see that a lot of your stories are taking 9 days or 10 days or just a long length of time, that means you might need to break down stories a little bit and iterate on those. Another thing we decided to track was throughput. So with throughput, you can do a unit, stories per unit of time. We decided to do stories per week. So this way, if you have 12 weeks to complete a certain amount of stories and your average output is 4 stories per week, you can plan a certain amount of stories for those 12 weeks. So that aids us in planning releases. One of the diagrams we have up here is our control chart. So this is just mapping some of our cycle time. You'll see that there was a dip there. That was when we were trying to get that prototype done. So that was just kind of foot to the pedal when we were trying to get a lot done. But again, with this, you get to see some averages, you get to see some medians. It always allows for a point of conversation. Again, one thing I said was there's high visibility for everyone across the team. So again, if a story takes too long, that allows our sponsor to come into and ask us why it may or may not be taking so long. So product metrics that we decided to take were task completion rate, usability questionnaire. One of the reasons we wanted to do some usability metrics was because this is heavily a user-centric app, and we feel like their buy-in to this is important to us. So task completion rate is the number of successfully completed tasks over the number of total tasks. Now, since we're using VR technology, a lot of people might not have exposure to this type of technology. You might interact with web apps every single day, but you probably don't use VR technology every single day for the average user. So for that reason, we ended up using the usability questionnaire as well. So if for some reason we end up finding out that we have a low task completion rate, but a high results on the usability questionnaire, that just might mean that a lot of people aren't used to using VR technology, or we need to educate them a little bit before letting them go into our tasks. Some of the factors that are going to affect our task completion rate and our usability questionnaire are environment. So depending on the environment that we do test users in, that can affect pixelation issues or anything like that. And then again, user knowledge, as I touched on, their knowledge of VR applications.
On top of that, we added in some new performance metrics that we will be taking in the following semester, because our main feature that we're giving to our users is this video feed, and we want to make sure that video feed doesn't drop, and we want to make sure the video feed is either the highest quality it can be in frames per second or resolution and have it still be within a certain degree of latency, so that the person still gets that feeling of presence. That's what we're trying to maintain here.
So for testing, obviously we're doing like a standard unit testing and other code coverage stuff, just as most other software projects do. But more specifically to our project, since we're really big on this feeling of presence, and there's no real good way to quantify like a measurement for like how much presence you can feel. As you mentioned before, in our usability questionnaire, we're going to be asking our users to compare what they feel from our system as opposed to in-person interviews and remote interviews. To validate our idea, we've interviewed many different users from different majors that could potentially be using our system, and each of our users' stories has a detailed description and a list of acceptance criteria it has to meet.
So now, what went well versus what didn't? So to start, our team had good communication. We were able to figure out our process pretty quickly. We came together. We didn't have too much internal conflict in forming the team. And next, we were able to define the scope of our project pretty well, and we kept good communication with our sponsor. However, we did have some issues with explaining solution complexity to him at first. So initially, he provided various technologies that could be viable solutions, and as a result, it took us more time than we liked to actually do the research and present as to why one solution might be better than the next. So for current status, we've iterated on a full prototype. So that includes the administrative functionality of managing assets. We also had the immersive background, so we wanted to kind of get the feeling of what it would be like to actually be inside the VR environment. And then the screen sharing aspect where we took the user's camera feed and put it into the VR. And now for, as a result of that, we were able to, so going forward, we were able to iterate on our project artifacts. So that allowed us to get a little clearer idea on what our architecture might look like and what the functionality we might need in the future would be. So with that, that meant that we were able to overcome some of the obstacles we saw that we might face at first. We also found some new ones earlier on.
So now we're going to walk you through a little demo of what our application exactly does. Momentarily, we're going to show you what our application is.
Yeah.
So I want to use my laptop.
So what we're going to walk you through is Dominic has been invited for an interview with Micro Gugazon. He's going to click the link, and he's going to go into an interview with Micro Gugazon, highly revered company in tech. As the page loads up, it's going to process some of our image applications and also start some of our WebRTC stuff. So you can see I'm to the right and Dominic is to the left. You can see some of the green pixelation issues, and we kind of did this on purpose as well, just to show you that lighting can affect our application. So this was, again, talking about environment before. Depending on how much lighting you have in the application, this will affect the amount of green pixels that are there. If you look at me in that application, all the pixels were chroma keyed out, but for Dom, it was a little bit different. And then we did end up putting both people in there just to kind of show a proof of concept that we can get two people on different peer-to-peer networks and we can get them to interact. So going forward, of course, it would only be one person showing up. So if Dom entered, he should only be able to see me, no pixels or anything like that. And then we would also have an environment where he could drop his work and show it to the interviewer as well.
Let's go down. Okay. All right, last slide, guys. This is almost over. All right, so for semester 2 plans, we're going to try to use our prototype findings right now to plan new features. We want to continue research and our implementation regarding our video streaming and video parsing. We would like to obtain higher quality 360 images to provide immersive backgrounds. And we're just going to start our release schedule, which should hopefully try to conclude by the end of April. And last but not least, we decided recently that we wanted to add a new metric called SSPR, Sponsor Smiles Per Release, or as I like to call it, the Bondi Scale of Approval. So we'll be watching next semester. And with that being said, questions?
Elevators like that job answer that they don't have like all the screens, like you're like looking at itself.
Yeah, so that's what we were showing. That was just a little bit of a proof of concept that we can actually get two users into the application that are on two different computers. So again, like when we would iterate on it, as the interviewer would come in, he wouldn't be able to see himself. He would only see the interviewee in a fixed space. So like it would basically be shown almost on a chair, like how you're sitting right there. Yep, I believe we had a question here. Yep.
So how did you manage the customer's expectations since it was such a large-scale project effort?
So that was actually pretty difficult when we were coming into it in terms of the scoping. We did try to talk to him and talk through our complexity of solution. As Dan mentioned, what we ended up doing was providing research documents to show him what was viable and what wasn't. Also, iterating on the prototype and showing them our cycle time on some of the stories does help them understand exactly the complexity of some of these stories. And then again, our sponsor has been doing this for a while, so he does understand that you have other classes, and again, you're not putting 40 hours a week into this project too. Do we have a question?
Will this be just supporting rotational, or will it be supporting group scale VR?
This will be supporting, you're going to be fixated into one location at this point in time, and that will allow us to get the full view of the green screen effect. And yeah.
Anyone else?
You mentioned 3D scans. How are you going to do that for a person?
That's a
For
3D.
iteration 2?
Oh, okay, I think I meant to say 360. If I said 3D, I apologize. We kind of have out of scope 3D scans because it's kind of hard to get a 3D scan of actual person into VR. So we just want to get 360 images, put it into VR, so it's kind of about an immersive feeling.
Yeah, the scans are mainly for like designers. Let's say you have a bag or something we're scanning that, not people. But scanning people is still out of scope.
Yeah. So do both users have to provide their own green screens in the user application?
Yeah, so this application can be used from multiple media. So maybe say like one person has a green screen, one person doesn't, that's okay. One person could have a VR headset and then they're inside the VR application and maybe they don't have the green screen aspect of the video cam on them per se, but they're looking through the VR application. So if you wanted to have both green screens, then yes, you would both have to have those.
Also, Jim has told us he has unlimited funds, so we will be.
So for the person wearing the VR headset, when they have like an avatar?
That's a good question. We have looked into avatars right now. We looked into a research paper that has done almost very similar thing to what we are doing right now, and they have looked into does it look weird when someone's looking at you with a VR headset on in this environment, and they actually were rated 4 out of 5 on the consumer a very disagree to a very satisfied rating. They actually rated it 4 out of very comfortable for them to be viewing people with the headset on, even though you don't have direct eye contact.
Any other questions? Cool.
Thank you.